Hello everyone, this is Anita Raghavendra from the Department of Electronics and Communication Engineering, MIT Mysore. Okay, so in this session, I will be explaining you about the subject called Basic Electrical Engineering. All branch students are going to study this subject in first year. Okay, so before coming to the contents, so let me introduce you the modules which you are going to study in this particular subject. Okay, so these are the contents which you are going to study in this subject. So in module 1, so you have DC circuits, AC fundamentals. Okay, and in the module 1, so you have two concepts like DC and AC, right? So what is this DC and AC? So DC and AC stands for direct current and alternating current. So what is direct current? Direct current means the current, okay, flows always in one direction, and of course the magnitude of the current remains constant, or it is constant with respect to time, right? So in this way, so we just consider the current, right? So this is current and the magnitude of the current, so it is constant with respect to time. This is nothing but DC current. And AC current means, so here the direction of the current changes alternatively, is nothing but alternating current. Okay, so like here the circuit which has a DC source of energy is nothing but DC circuit, and the circuit which has AC source of energy is nothing but AC circuit. So AC circuit you are going to study in module 2, that is the first chapter in module 2. Okay, and before you learn AC circuits, you are going to learn some of the fundamentals in AC. That means how the alternating current generates, right? And some of the terminologies which we are going to use in AC circuits, that you are going to study in AC fundamentals. Okay, and in module 2, so you have AC circuits. As I have already told you, the circuit which has AC source of energy is nothing but AC circuits, right? And whenever we consider AC circuit, it is understood that it is a single phase AC circuit. Okay, so in the next chapter, that is in module 2, second chapter, so you have three-phase AC circuits. Okay, so here in this chapter, that is first chapter in module 2, so we have single phase AC circuits, and in the second chapter, three-phase AC circuits. Next we have module 3. So in module 3 again you have two topics, two chapters. So one is transformers and another one is domestic wiring. So you might have heard about the word called a transformer. So it is a device which transfers energy from one point to another point, okay, without any electrical connection. So which transfers electrical energy from one point to another point without any electrical connection. So that is nothing but transformers. So here you are going to study about the different types of transformers and the construction of the transformer, then working principle of transformers, and of course the application of transformers. And in the next chapter, so domestic wiring. So in this chapter, domestic wiring, so you will be learning about like meter board and distribution board, then necessity of earthing. Okay, so you might have heard about this word called earthing. So earthing, and what happens if earthing is not done, and types of earthing, and then precautions against the shock, right, and preventions of shock. So these concepts, and along with this, like how we can control a single lamp using 2 switches and 3 switches. So these things you will be familiar with in this topic, okay, domestic wiring. So next in fourth module, so you have DC machines, right? So the fourth module deals about DC machine, and fifth module deals about AC machines, right? So as I have already told you, this AC and DC stands for direct current, and the AC stands for alternating current. So in fourth module, so you will be learning about DC machine, and which consists of two topics again. One is DC generator and another one is DC motor. Okay, so where you find it in like dynamo, so in automobiles, okay, DC generator and DC motor, right? So before that you should be knowing the definition of generator and motor, right? So motor means when it converts, like any device which converts, okay, electrical energy into mechanical energy, so we call it as motor. And generator means, so vice versa, that means the device which converts mechanical energy into electrical energy is nothing but generator. Okay, so in this chapter, so you are going to study about DC generator and DC motor. And in the 5th module, so again you have 2 topics. So one is synchronous generator, we also call it as AC generator, and the next one is 3-phase induction motor, we call it as AC motor. Okay, so this 3-phase induction motor, so you find it in industry applications. Okay, so these are the contents which you are going to study in this particular subject. Okay, with this content, so we have course outcomes. Okay, so course outcome means after studying this subject, so what students is going to learn, okay, what they will be learning, or that is the outcome of this subject, right? And the first CO, so in a short form we just represent it as CO, course outcome, and we have 4 outcomes here. So the first outcome is, so students will be familiar with, okay, the working principle of AC and DC machines, right? AC DC machines means AC generator, AC motor, and DC generator, DC machines means DC generator and DC motor. Okay, and by applying the concept of electromagnetic induction theory, right? And next one is CO2. So CO2 means, so here determining electrical parameters in AC and DC circuit. So when any circuit is provided, so students will be able to understand what type of circuit, that is by applying the concept of electrical laws. Okay, electrical laws like Ohm's Law and Kirchhoff's Law, so like different electrical laws. And next we have CO3. CO3 is, so here of course the students will learn the electrical safety rules and standards. Okay, what type of electrical safety rules and standards to be followed, okay, in domestic wiring purpose. Next we have CO4. So in CO4, analyze the behavior of AC system. Okay, and here in first 3 O's you are going to apply, okay, to understand all this, and in the last CO here, so you will be analyzing the behavior of AC system. Okay, so these all about the content, and related with respect to the content, these are the COs. Okay, now I will be explaining you about the first module. So first chapter in the first module, that is DC circuits, right? And here in DC circuits you have the laws or the concepts called Ohm's Law and Kirchhoff's Law. Okay, and based on this Kirchhoff's Law, so we have another 2 concepts, that is series combination of resistances and parallel combination of resistances, right? And before I introduce the concept or the laws like Ohm's Law and Kirchhoff's Law, so let me explain you, so what is DC circuit? Okay, remember DC circuit means a circuit which consists of, right, which consists of DC sources of energy and only resistances. That means to say, so here we have DC sources of energy, so we can represent it in this form. This is DC source of energy and only resistances. Okay, and this can also be the symbol can be represent in this form also. Okay, DC source of energy, as I have already indicated. So DC circuit means the circuit consists of DC source of energy, so it can be represented both the ways, and only resistances. So now you will be familiar with identifying DC circuit. Okay, and so what is circuit analysis, right? Once you identify the circuit, that is once you identify the DC circuit, you need to analyze the circuit. Circuit analysis means finding out the voltage or the potential difference across the point and the current passing through any conductor or through any resistor. So this is nothing but circuit analysis. Mainly DC circuits depend on 2 laws, one is Ohm's Law and another one is Kirchhoff's Law. Okay, so now we are going to discuss about the first law, which is Ohm's Law. So it gives the relationship between voltage, current and resistor. Okay, remember it gives a relationship between voltage, current and resistor. Okay, so here Ohm's law, what is a statement? What is the statement of this Ohm's law? So, right, so potential difference between 2 points of a conductor is directly proportional to current passing through the conductor. Okay, so let me repeat, potential difference between 2 points of a conductor is directly proportional to current passing through the conductor, keeping the physical parameter constant. Okay, keeping physical parameter constant, physical parameter like temperature, pressure, okay, etc. Okay, so this is the statement of Ohm's law. Now this proportionality is replaced by a constant which is R. This proportionality is replaced by a parameter called R, so that is resistance. Now finally, so we have V is equal to R into I, or V is equal to I into R. Okay, this we get from the Ohm's law. Right, and once we state the Ohm's law, once we understand the concept of this Ohm's law, so we need to understand the limitations. Okay, where and all Ohm's law can be applicable. So we need to understand the limitations of Ohm's. So there are 3 limitations of Ohm's law. So one is Ohm's law cannot be applicable to non-linear devices, right? The first limitation is Ohm's law cannot be applicable to non-linear devices. Non-linear devices like diode, transistor, okay? So that is first limitation. And the second limitation is, so Ohm's law cannot be applicable to non-metallic conductors. So that means it does not hold good for non-metallic conductors. Example, silicon carbide. That is the second limitation. And the third limitation is, so Ohm's law does not hold good for metals which gets heated, okay, which gets heated up during the flow of current. Okay, that means to say like when the current flows through any conductor or through any metal or metal, so when that gets heated up, so it cannot be applicable, or it does not hold good for metal, right? So when it gets heated during the flow of current. So these 3 are the limitations of Ohm's law. Okay, after Ohm's law, so we have another law called Kirchhoff's law. Okay, again under Kirchhoff's law, so we have 2 types of laws. So one we call it as, in a short form I'll write it as Kirchhoff's current law, and another one is Kirchhoff's voltage law. Okay, so we have 2 laws under Kirchhoff's law. So one is Kirchhoff's current law, the C stands for current, and so next one is in a short form I write it as KVL, V stands for voltage, so Kirchhoff's voltage law. Okay, so now let me introduce the law called Kirchhoff's current law. Okay, so now I will be explaining you about Kirchhoff's current law, and which we call it as KCL, right? Okay, so here the statement of Kirchhoff's current law is algebraic sum of the current meeting at a junction, okay, is equal to 0. Okay, how do we write in terms of equation? So algebraic sum of the current meeting at a junction is equal to 0. Okay, algebraic sum of the current meeting at a junction is equal to 0. So we can have any number of branches here. So let me consider this as J, so where J varies from 1 to K. That means we can have any number of branches, that is K number of branches. Okay, so I will just I will be explaining you this equation with an example, considering this as an electrical network. Okay, so here assuming this as I1, this as I2, look at the direction of the current here. So I1, I2, I3, I4, I5, I6. Okay, so look at this network, or look at this circuit. So here what I have indicated here. So algebraic sum of the current meeting at a junction. So where is the junction over here? So this is the junction point where two or more terminals meet. So what is junction? Where two or more terminals meet. Okay. So now algebraic sum of the current meeting at a junction is equal to 0. Right. So now, so how many branches we have? We have 6. That means K is equal to 6. Now, how can we write this expression? How can we expand this expression? So now, and considering the current which is coming or which is flowing nearer to the junction is considered as positive, and the current which is moving out of the junction is considered as negative. Okay, or vice versa you can have. So with this circuit, I can write this equation as, so if G is equal to 1, now the I1 current is entering the junction, then I have told you that the currents which are entering the junction is treated as positive, and the currents which are leaving the junction okay, are considered as negative. So now I can write this expression as plus I1 because it is positive, then plus, and if G is equal to 2, so G is 2 which is entering the junction, then it is again positive. Next, similarly, so we have plus I3 because I3 current is also entering the junction, but what is I4? So I4 is leaving the junction, then this will be treated as minus I4. So minus I4 minus I5 minus I6 is equal to 0. Okay, this is how we have expanded this expression, right? So, and with this again I can write one more equation as I1 plus, I can rewrite this equation as I1 plus I2 plus I3 is equal to I4 plus I5 plus I6. Okay, so one statement is algebraic sum of the current, okay, sum of the current meeting at a junction is equal to 0, and in other case, in another form, so we can also state Kirchhoff's current law as algebraic sum of the current entering the junction is equal to algebraic sum of the current leaving the junction. Okay, because based on the last equation we can state that algebraic sum of the current entering the junction is equal to algebraic sum of the current leaving the junction. Okay, this is all about Kirchhoff's current law. Okay, so next we have Kirchhoff's voltage law. So in a short form we call it as KVL, right? So now let's look at the statement of Kirchhoff's voltage law. So here algebraic sum of the product of current and resistor is equal to algebraic sum of EMF in a circuit. Okay, so look at the statement here, algebraic sum of the product of, right, you are multiplying. Okay, so you are multiplying I with R. So product of current and resistor is equal to algebraic sum of the EMF in a circuit. Okay, and in another form, so we can also state that algebraic sum of the branch voltages in a closed loop is equal to 0. So both are right. Okay, algebraic sum of the branch voltages in a closed loop or in a closed circuit or in a complete circuit is equal to 0. So this is the statement of Kirchhoff's voltage law. So I will be explaining you this along with the circuit. Okay. As I have already told you that DC circuit consists of a DC source of energy and only resistances. So here considering two resistances R1 and R2, and along with this voltage source, and one terminal is positive and another terminal is negative. Okay, so let me explain you this voltage that is Kirchhoff's voltage law with this circuit, and there is a flow of current, we call it as I. So here now how do we apply? Okay, how we can apply this law here in this circuit? So remember So whenever the current flows in this direction, look at the direction of the current in the circuit. So when it is moving in this direction, right? So here there will be rise in voltage. So this will be treated as plus V. Then here, so there will be a drop in voltage, okay. So whenever we have a resistor here, so what happens, there will be a drop in voltage, okay. Voltage drop will be there. So minus because the current gets multiplied with R1, so I into minus I into R1 minus I into R2 is equal to 0, okay. So now look at the circuit here, and with this circuit, so this is raising voltage, then so here there will be a drop in voltage, then here this will be considered as plus V minus I into R1 minus I into R2 is equal to 0, and in another way this can be written as V is equal to I into R1 plus I into R2. So finally we can write this as I. You can take I common from this equation, so we get this equation. So finally we can write V is equal to, finally we can write this equation as V is equal to I into R equivalent. So don't you think this equation satisfies the first equation? Yes. So algebraic sum of the EMF in an equation. So you can have any number of EMFs like this, okay, in a circuit, and similarly this is equal to, so algebraic sum of the product of current and resistor, or as I have already indicated, or as I have already told you, so here algebraic sum of the branch voltages in a closed loop, okay, in a closed circuit is equal to 0, okay. This is all about Kirchhoff's voltage law. So in the next topic we are going to discuss about the series combination of resistances and parallel combination of resistances based on the Kirchhoff's voltage law and Kirchhoff's current law, okay. Next we have series combination of resistances, okay. So look at the circuit. Series combination of resistances means, so we can have any number of resistances, okay, and connected one after the other, right. So one after the other, and similarly, but in this example I have taken only 2 resistors, but similarly you can have any number of resistors, and which should be in series, that is nothing but series combination of resistances, right. So how we are going to analyze this kind of circuit, okay, that this part I will be explaining. So here you can see 2 resistors R1 and R2, and of course the same current flows through R1 and R2, and we have one DC source of energy which is considered as V, okay. And look at the polarity again, plus and minus, because this, okay, the large one is plus and the small one is minus, right, okay. So initially, okay, in this circuit you need to apply KVL, right. So KVL means Kirchhoff's voltage law, and before that, so you need to write, so this is V1 and this is V2. So what is this V1 and V2? Here this is the applied voltage or the DC source of energy, and so when the current passes through this particular resistor, so there will be a different voltage, okay, and even when the same current flows through the resistor R2, so you will get a different voltage, we call it as V2. So remember voltage here, finally we can have V is equal to, this is V1 plus V2. So remember voltage gets divided in a series combination of resistances, that is with respect to the based on the resistor. Before again I write the equation, so you need to understand some of the characteristics of series combination of resistances, right. So what are those characteristics? See, the main characteristic in this circuit is the current remains same through all the resistors, right. The first characteristic is the same current flows through R1 as well as through R2, that is the first characteristic. And the second characteristic, so what is the second characteristic? Here the voltage gets divided, okay, because V1 you find out across this R1, and V2 we find out across this R2. Okay, so voltage gets divided. So based on this, so we can write V is equal to V1 plus V2. So this is the second characteristic. Now here V is equal to V1 plus V2. So what is V1? V1 is equal to I into R1. So I into R1, so you can see here. Then so what is V2? V2 is nothing but I into R2, because the same current flows through R2, so we get I into R2. Now we can write, so take I common from here, so I common R1 plus R2. So finally we can write I into R equivalent. Okay, I into R equivalent. See here, so here it satisfies Ohm's law as well as Kirchhoff's voltage law. Okay, and what is R equivalent? So R equivalent is equal to R1 plus R2. R equivalent is equal to R1 plus R2. So similarly we can have n number of resistors. So similarly we can have n number of resistors. So that means R equivalent is equal to, so R1 R2 plus n so on. So till this R n. This is the general equation for R equivalent. Okay, so this is about the series combination of resistances, and with this basis, so you need to understand the concept called voltage divider rule. Okay, right. So voltage divider rule, that means how we can calculate this V1 and V2 individually, okay, without having the value of current. Right. So how we can calculate the value of V1 and V2, right? So here, because if you just consider this circuit, so straight away I can write V1 is equal to, this I into R1 and V2 is equal to I into R2, right? So what is this I? Because I have told you that V1 should be calculated without having the value of I. So how it is possible? That means with the help of only applied voltage. That is nothing but voltage divider rule. Okay, with the help of applied voltage. So so here we are finding out the value of V1 and V2, that is voltage divider rule. So how it is possible? Now, so you know that V is equal to I into R equivalent, right? And where R equivalent is equal to R1 plus R2, right? So what is I here? I is equal to V divided by R equivalent, and straight away I can write this as R1 plus R2. So now substitute this equation here. Then you will be getting this as V into R1 divided by R1 okay. So now substitute this I equation in this equation. So you get V1 is equal to V divided by R1 plus R2 into R1. Okay, so finally V1 is equal to V into R1 divided by R1 plus R2. So this is V1. And similarly we can have another equation which is V2. So what is V2? You know that V2 is equal to I into R2. So similarly substitute the same I equation here, then you will be getting V into R2 divided by R1 plus R2, which is V2. So with the help of Kirchhoff's voltage law and in series combination of resistances, we can calculate the value of V1 and V2. Okay, so using applied voltage, this is called voltage divider rule. So this is nothing but parallel combination of resistance. Okay, so now let me explain you how we can analyze this particular circuit. And before that, so you need to understand the characteristics of this particular circuit. So what is the first characteristic? So here current gets divided. remember here the current gets divided, which is I1 and I2, that is the first characteristic, and so voltage remains same. See, look at this circuit. If I just find the voltage V1, what is V1? That is across R1. Don't you think the voltage across this R1, voltage across this R1 is same as voltage across this R2? Right? Because see here, voltage across this R2 is treated as V2 and voltage across this R1 is V1. So both are same, and these two voltages are same as the applied voltage. So remember, there are again two characteristics. One is voltage remains same, and another characteristic is current gets divided as I1 and I2. Okay, depending upon the number of resistors in a circuit, or depending upon the number of resistors connected in parallel in a circuit. Okay, and so with this circuit, initially, so I is equal to, you know that I is equal to I1 plus I2. Okay, look at this circuit, look at this circuit. So you have total current I, so later the current gets divided, okay, based on the number of resistors connected in parallel. But in this particular example, since we have taken only two resistors, so you can write I is equal to I1 plus I2. So what is I1 in terms of voltage? Which is total voltage divided by this R1. So V divided by R1 plus V divided by R2. And now you can take V common, and this can be written as 1 by R1 plus 1 by R2. So I is equal to, finally we can write I is equal to V, okay, so divided by this R equivalent, right? I is equal to V by R equivalent. So what is R equivalent? R 1 by R equivalent is equal to 1 by R1 plus 1 by R2, okay, in this particular example. And similarly you can have any number of resistors, that is n number of resistors. This is the general equation, right? With the help of this concept, so you will be learning about another rule called current divider rule. Okay, so here you know what is I1. I1 is equal to total voltage, applied voltage divided by R1, and I2 is equal to V divided by R2. So now we need to replace this voltage, because you are going to express this I1 and I2 in terms of total current. Okay, remember, you are going to express I1 and I2 in terms of total. Example, we can write 1 by R equivalent is equal to 1 by R1 plus 1 by R2. And if you further simplify this expression, so R equivalent becomes, you will get R equivalent as R1 R2 divided by R1 plus R2. Okay, now I am going to substitute this R equivalent here. Okay, so V is equal to I into R1 R2 divided by R1 plus R2. Okay, now you substitute this V here. So if you substitute V here, then you will be getting I into R1 R2 divided by R1 into R1 plus R2. Okay, so now R1 gets cancelled. So finally we can write I1 is equal to I into R2 divided by R1 plus R2. This is I1 equation. And similarly we can have I2 as, I2 equation as, so you get the same total current, okay, and so instead of this R2 you will be getting R1 divided by this R1 plus R2 remains same in the denominator. Okay, okay, you can express both I1 and I2 in terms of total current. This is nothing but current divider rule. Okay, so you have learnt about how the DC circuit looks like, and Ohm's law, then Kirchhoff's law, under Kirchhoff's law, Kirchhoff's current law, Kirchhoff's voltage law, and with the help of Kirchhoff's current law and voltage law, so you have learnt about series combination of resistances and parallel combination of resistances. In series combination of resistances, you have learnt about voltage divider rule, and parallel combination of resistances, you have learnt about current divider rule. Thank you.